The next sort we're going to learn about is called selection sort, and it is far better than bubble sort and BOGO sort. Remember, BOGO sort, we just kind of threw values up in the air and hoped they landed in the right spot. Did that over and over again until we get lucky. Bubble sort, we bubbled up the values one at a time by doing swaps with values next to each other. And selection sort is going to be an improvement mainly because it decreases the number of swaps we need to do. So here's how the algorithm works. So here's an array of length 5, and you'll notice that there's 7, there are two 2s, a 5, and a 3, and I'm going to differentiate the two different 2s by putting a star next to one of them. So I know that this 2 is to the left of the second 2. So what we do is we start at the beginning of the array, and we assume that the value at the beginning of the array is the biggest, and then we find out if we're wrong and go throughout the entire array. So I'm going to assume 7 is the biggest. Check, 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 check. Nope, we were right. 7 was the biggest. But we know that it's in the wrong spot because it needs to go to the end of the array. So we're going to fix that by doing a swap with the biggest value to where the biggest value should be. So that means the 2 and the 7 are going to switch positions, and the other values will stay in their regular spots. So you notice in one stage, we have accomplished getting the biggest value into the right spot by doing only one swap. Whereas in bubble sort, it's going to take 1, 2, 3, 4 swaps to get the 7 in the right spot. So that seems to be a pretty big improvement. So now 7's in the right spot. So I'm going to put a little wall here so we don't look at it anymore. Because the next step, we're going to try to find the biggest value for the rest of the array. So I start at the beginning. 2 looks like it's the biggest. Still the biggest. Nope, sorry, 5 is the biggest. Yep, 5 was the biggest. So because this is the spot where the 5 needs to go to, I'm going to swap the 5 and the 3. So 5 and 3 swap, and the other values in the array stay put. So now I can put a little wall here knowing that I have put 5 and 7 both in the right spot. Now one thing hopefully you've noticed at this point is that the 2 star and the 2 are in different orders than they were before. Initially 2 star was less than 2, or at least to the left of 2. Now it's to the right of the other 2. So that we're going to get into more later, but that's going to be an issue. So now we're only going to look at these 3 values. We start at the beginning. The 2 is the biggest. It was still the biggest. Nope, we're wrong. The 3 is the biggest. And you'll notice that 3 is in the right spot, but in the basic version of selection sort, if a value is in the right spot, you still technically swap it with itself. So 3 just kind of comes back to itself. 5 and 7 stay put. They're all sorted. And I've got 2 and 2 star. The last stage here, we start with 2 being the biggest. And then 2's not, this value here is not any bigger. So we'll just assume that 2 is still the biggest. So it needs to swap over to here. So these two 2's swap positions, and the rest of them stay the same. And at this point, we've guaranteed that all the values to the right of the line are sorted. So since there's only one more value to the left, it must already be in the sorted position because it's smaller than all the other values, or at least not any bigger than them. And so now our array is sorted. So some things about this. You should notice that it took 4 stages, just like bubble sort did, but significantly fewer swaps. And so when we're going to write the code for this algorithm, it's going to be similar to how bubble sort would work. So if I went all the way to array.length here for the number of stages, that would mean if my array was length 5, I'd have 5 stages. Because I only have 4, it should be minus 1. So that'll give me the right number of stages. And then in the algorithm, what you do, and I'll demonstrate this with the array to the right, is you always make a guess on the maximum index. And the maximum index to start is always 0. So in this algorithm, I would start with 5 being the biggest value, so my max index is 0. And then I'm going to go through the array, checking spot by spot, and see if there's a bigger value in it. And there aren't any, so therefore I need to swap the 5 and the 2, and they would swap positions, leaving the 1 and the 3. Okay, that seems easy enough. The tricky part is this inside for loop, because I have to repeat this algorithm. And the I value is going to be the numbers that I'm checking through. And remember from the first time, that value needs to stop based on where a wall is. So we're going to have to figure out how far I is going to go. A first step is to say, well, I should go no up to but not including the length of the array. Okay, that seems right, but that would mean we go all the way to the end every time. So we need this maximum value or maximum index that I gets to go down by 1 each time. So the first time it goes all the way through, the next time it goes all the way to the end, but not the last one. So we're going to have to subtract something here. So this ending position gets lower each time. And it turns out that the stage is the right value to put there. Because in the 0 stage, you're going to go all the way to the end. So in stage 0, you go all the way to the end and swap the 2 and the 5. In stage 1, so here's stage 1, I go from 2 being the biggest, then 1, 2 still the biggest, 3 is now the biggest, and now I need to stop because I only go up to array.length minus 1, and I go less than that. So it is going to stop correctly. I'm going to notice that 3 is the biggest. It does a little loop-de-loop and stays there. 5 stays there. The max index turned out to be 2, even though it started at 0. And the other 2 numbers would stay in their position. So going up to array.length minus stage will terminate the loop looking for the right position to swap to correctly. Now, what do you do in the if case? So this is where we're checking if we have a bigger value than what's at the maximum index, or at least what we think the max index is. And we do that by doing if array at I is bigger than array at max index. Because if that's the case, then we have just found a value in the array in our search region that is bigger than where the max index is. So that means our guess of where the maximum index is wrong, and it should actually be at position I. I forget my semicolon there too. So notice that there's a difference here. Here we're comparing the values in the array, and here I'm assigning the position, because that's all I'm keeping track of. The last thing we need to do is, after this loop is done, we have found the maximum index in our part of the array. And so now we have to do a swap. So let's assume I have a swap command so I don't have to write out all 3 lines. I'm definitely going to have to swap the array, and I have to specify what 2 positions I'm swapping. The max index is the position where we have found the biggest value. Where we swap to is going to change just like this loop conditional did. It's going to be array.length minus 1 so that we go within the bounds of the array, and then minus stage, so as the stage increases, our position at which we're swapping to is going down by 1 each time. And if you run this code in Eclipse and compile it, it will successfully selection sort an array of integer values. So that's how the algorithm works. Now, a couple analysis type issues for the selection sort algorithm. We said that the number of stages was the length minus 1, so if the length is n, the number of stages is n minus 1. Now, the number of comparisons is interesting to figure out, because if you have an array of length 4, so let me scroll up again here. So in the first stage, you had to compare once, twice, 3 times. In the next stage, you had to compare 2 times. In the next stage after that, you had to compare 1 time. So it's a total of 6 times if you have an array of length 4. And the same thing happens if you have an array of length 5. It's 4 plus 3 plus 2 plus 1, which is 10. And earlier in the year, we talked about how to calculate the sum of the values of consecutive integers. And the algorithm is, for n values, it's n times n plus 1 over 2. For those of you who know a little fancy summation notation, the summation from 1 to n of I is n times n plus 1 over 2. So that's the way you add up n consecutive numbers. Now, the one caveat for here is that our n is the length of the array, but the number of comparisons in the first stage is n minus 1. So the algorithm is roughly the same, but it's n minus 1 times n all over 2. Now, the important thing to know about this is not that number. The important thing to know is that's about n squared, quadratic. So if you looked at the graph of how long it takes to do selection sort, the graph would look something like this. So as the number length of the array increases, the number of comparisons increases quadratically, which essentially means that your running time is going to increase quadratically. Now the number of swaps is easy because in each stage you do one swap, so there's n minus 1 swaps. Stability refers to whether or not the values in the array that are equal stay in the same order, and that's where we're looking at the 2 star versus the 2. And if you remember, they're position switched, so this is not stable. So it is no. They switched. And a lot of sorts are not stable. It's not a huge issue, but some people think stability is important. And in certain applications, it could be important. But for the most part, stability isn't that important. Now, when does it work really well? It works really well kind of all the time. It doesn't really have a worst case. The worst case, I guess, is if it's already sorted because you're doing a lot of swaps for stupid reasons because they're already in sorted order. So it also works poorly, kind of never. It's very consistent. It's not particularly efficient overall, and we're going to learn about sorts that are faster than that. But overall, it's a very consistent algorithm, so its running time is very predictable. And don't really have anything for the miscellaneous category for this sort. That's about it. That's selection sort. So hopefully that helped a lot in understanding how the selection sort algorithm works. That's all.